Okay, so we're going to have a look at another question from the 2020 HSC Advanced Maths paper. So this is now question 28. So we're told in a particular country, the hourly rate of pay for adults who work is normally distributed with a mean of $25 and a standard deviation of $5. So straight away we can draw a diagram of this. This is a bell curve. So centered at 25. This is the median. In the case of a perfectly normal distribution, the median is the mean and is the mode. These are all the same. It goes down to 20, down to 15, down to 10, up to 30, up to 35, up to 40. Now we know all the percentages here. Pretty much you should have memorized these by now. 34% in here, 34% in here, 13.5% down here, 13.5% down here. We then have 2.35% here, 2.35% here, and 0.15% on either of the tail ends. So we're told two adults who both work are chosen at random. Find the probability that at least one of them earns between $15 and $30 per hour. So find the probability at least one of them. Well, we need the probability that someone earns between 15 and 30. So probability of 15 to 30. From our normal distribution, we can see this is all of this area. So 34 plus 34 plus 13.5, this will be 81.5%. So there's an 81.5% chance a person chosen at random will earn between 15 and 30. Now, at least one, we've got to be careful with the wording here. At least one means one of them or both of them. So this is the way we're going to calculate this, the probability that of the two of them, so at least one earning 15 to 30, is going to be 1 minus the probability that neither of them earn between 15 and 30. So this is 1 minus the probability of neither, which is going to be 185 squared. Because if there's a probability of 0.815 that they do earn between that, then 1 minus that will give you the probability they don't. You need two lots of that, so the chance that both of them don't earn that is 0.185 squared. All probabilities minus that is at least one of them earning between 15 and 30. So we have 1 minus 0.185 squared, and this gives me 96.5775. So therefore the probability we're after here is equal to 96.5775 ... So therefore the probability is about 96.58 to two decimal places. And this is as a percentage. And this is the answer to question A. Now for part B, we are told the number of adults who work is equal to 3 times the number of adults who do not work. One adult is chosen at random. Find the probability that the chosen adult works and earns more than $25 per hour. Okay, so we've been told the number of adults who work is equal to 3 times the number of adults who don't. That means 3 of 4 adults work. So the probability that someone works is 3 on 4. Now, the probability they earn more than $25 per hour from our diagram, that's this top half, is 50%. So the probability that they earn 25 or more is 1/2. And so this is just going to be a product. So the probability that someone works and earns 25 or more is going to be 3/4 multiplied by 1/2. This is 3/8, and this is the answer we're after. And this can be left as a fraction in this case. We could also convert it to a percentage. We did convert to a percentage in the first case. So this becomes 37.5%. So you could say this is 37.5%. So either of these will be perfectly fine. If you're going to do the percentage, best to list the fraction as well. And this is what we're after here. Now the marks for this question, this is a 5-mark question. Again, the first part is worth 3, the second part is worth 2. For the first part, you need something along the lines of the probability that a single adult earns between $15 and $30. For the second part, you will need to extend this somehow to begin to find the probability that 2 can earn this amount. Now there's a few different ways you could do this. The markers will be quite generous on this type of question because you could find the probability that both of them don't. That might count. You could find the probability that one doesn't, one does. You could draw a tree diagram. There's a whole bunch of ways to go here. And then to get the third mark, you need the correct solution, which in this case was 96.5775 or 96.58 to 2 decimal places. It doesn't specify rounding, so we don't need to round. You can just leave the answer as it's in its full form. For the second part, the marking is reasonably straightforward. You get 1 mark for finding a probability either that the person works or that they earn $25 or more. So this first part will get you 1 mark. The second mark, you will need 3/8 or 37.5%. So you'll need the correct answer.